Okay, today we'll take a look at two more problems from the 9 chapters of the mathematical art, also known as Jiuzhang Suanshu in Chinese. So we're looking at first chapter, 方田, rectangular fields, and that chapter is mainly focused on calculating the area of different shapes, two-dimensional planar shapes, and also the arithmetic of fractions. So for today, we'll take a look at the first two problems on the arithmetic of fractions, notably the reduction of fractions or simplifying fractions. So we'll begin by analyzing and interpreting the classical Chinese text, the original text. And this is problem 1.05, fifth problem. It says, 今有18分之十二. 问约之得几何? 答曰三分之二. So what does this translate to? It says, suppose there are 18 out of 18 parts, 12 or 12/18ths. So I can write that down on the side here, 12/18ths. That's the number we're trying to reduce. And they're asking, question, what do you get after you reduce the fraction? Or reducing the fraction gives how much? That's what it literally translates to. And the answer is 三分之二, 答曰. That's the answer is 三分之二. So out of 3 parts, 2, which is the same as 2/3. So this is true even today in modern Chinese. The word 分 means parts of or to separate. And when it comes to fractions, they first state the denominator before the numerator. So it's saying out of 3 parts, there are 2 parts. That's what it means. Okay, so for 1.06, we see the next problem says, 又有91分之49. 问约之得几何? 答曰13分之七. Okay, so here it says 又有, which means suppose there is another, and suppose there are 91 parts of out of 91 parts, 49. So that's the same as 49 out of 91. And they're asking, okay, question, 问 question. 约之得几何? So after simplifying or after reducing, how much do you get? And answer is, out of 13, there's 7. Okay, so this is a pretty standard problem, and it's involving the reduction of fractions. So we'll take a look at the method prescribed in the original text. So in the original text, they call this method the 约分术, which means method of reducing fractions or method of simplifying fractions. So 约分术曰, so that means the reducing of fractions method states 可半者半之, 不可半者副置分母子之数, 以少减多, 更相减损, 求其等也, 以等数约之. Okay, so what does it say? So 可半者半之, you have to understand what this means in Old Chinese. So in ancient Chinese or classical Chinese, 者 is a term not only for a type of person, but anything. So they're saying that things, and here what they're referring to here as 者 is actually the numerator and the denominators. So if the numerators and denominators can be halved, that's what 半 means, by the way, that means halved. Maybe let's write the word have, or maybe havable. Then you have them. And if they cannot be halved, 不可半者 means if the numerators and denominators cannot be halved, 副置分母子之数 means on the side, you should set the numbers of the denominator, which is called the 分母. So that's the denominator. I'm going to put denom here for 分母. And 分子, okay, so that's going to be the numerator. I'm going to put num for numerator. The numerical values. And what you do is the next step. 以少减多, use the lesser number and subtract that from the greater number. So likely you're going to use the numerator and take that away from the denominator, because these fractions that are presented in the questions are not top-heavy or improper fractions. Okay, and the next step says 更相减损. So what this means is you're going to keep updating. That's what the 更 means. It means you continue updating this subtraction process where you use the the lesser number subtracting from the larger number, and then you got to keep doing that, 求其等也. So we have to understand what this word means. 等. So, this is if you know Chinese, this character means to wait, but it can also mean equal or to be equalized. So what it means here is until equality. You're going to keep doing this algorithm, this step, until you reach the same number on both sides. And 以等数. Okay, so this is now the equal number. I'll later explain what that means in modern math. Now use that equal number you acquired earlier to reduce the fraction. 约之, that means this as a verb to reduce. All right, so let's take a look at what they mean by the equal number. And what this method, the 约分术, which I should have underlined earlier, is essentially saying. So in modern math, and especially in Western countries, we usually call this method the Euclidean algorithm. Now, Euclid did explain the Euclidean algorithm in his Elements, but he demonstrated using straight lines, a bunch of different straight lines. But the gist of it is actually the same. In ancient China, they didn't focus that much on Euclidean geometry or just geometric construction, even though that was known to the carpenters. But they purely looked at this method of the Euclidean algorithm with numbers and arithmetic. So we'll just demonstrate what this method is like. We'll demonstrate how it works with some calculation. So let's begin with the first number here. The first number is 12 out of 18. Okay, so the method asks that if you can divide, if the numerator and denominators are halvable, you have them. And we can see that means if you divide, if your numerator and denominator are even, we can have them. So I'm going to just divide these by 2 right off the bat. All right, so that'll give us 12 out of 18. Why did I only write 12 out of 8? 12 out of 18. So we got to have both of these. So we get 6 out of 9. Okay, so 6 is even, that can be halved, but 9 is not. 9 is odd, so we can't have that, which means now we have to enter the algorithm of finding the equal number, 等数. Okay, so what you do is you take the smaller number, 6, and you subtract that from 9. So if we do 9 minus 6, that gives us 3. And then what you do is you're going to repeat this algorithm using 6. Okay, taking the 6, moving that there, and you subtract the 3. Okay, so larger subtract smaller. All right, you get 3, and 6 minus 3 gives us 3. Okay, so we see that we have 3 and 3 on the left and the right side of the equation here. So once we get to this stage, this is called the equal number, or the 等数. All right, so once you found the equal number, you are ready to reduce this fraction here, 6 over 9. Okay, so I'm going to divide the top and the bottom by 3. And that gives us, okay, 6 divided by 3 is 2. 9 divided by 3 is 3. And that is the answer provided. 三分之二, which means 2/3. Out of 3 parts, there's 2 parts. Okay, so we'll take a look at the next one. The next one is asking for, looks like it's 49 out of 91, right? 49 out of 91. And you do, well, first you look at the numerator and denominator. Are these even? No, they're not. So since they're not even, we can't just have them, which means we have to now enter the algorithm. 91 minus 49, let's see what that gives us. That gives us 42. Okay, so now you take 49 and you subtract the 42, and you get 7. Okay, so here it's unfortunate that we got this small number because we have to actually use the 42, subtract 7 from that, and you have to keep doing this subtraction by 7. So this will give you 35, and 35 minus 7 equals, looks like 28. And then you got to get 28 minus 7, which gives us 21. 21 minus 7. Let's see what that gives us. That gives us 14, right? 14. Okay, so 14 minus 7, that gives us 7. And lastly, we find that we're going to reach 7 equals to 7, and that's the equal number. Okay, so we found the 等数, the equal number. And that allows us to divide the top, the numerator, and the bottom denominator by 7. Let's see what we get. 49 divided by 7 is 7. 91 divided by 7 is 121. Okay, 13. So 7 out of 13. And that is the correct answer. And that's it for today. Very short video today. And I'll include the text and the translation in the description below. Feel free to subscribe, like, and subscribe. Thank you very much. See ya.